look at the exponent laws, the first one that we're going to see is the law of product of powers. So product of powers, produit de puissance. So here's how the law works is if you have the same base, that's the most important thing. You need the same base. You can when you're multiplying same bases, you can add the exponents together. Okay? So here are a couple of examples. So first example, I have a 6 to the power 5 multiplied by 6 to the power 4. It is the same base. So I can just kind of follow along the same example. It's equal. I'm going to write the base here, right? And then I'm going to write both exponents. So instead of m and n, it's going to be 5 plus 4. So my answer is going to be 6 to the power of 9. And I just leave the expression in form of a power. Same thing here. My base is negative 2. Here, negative 2. So it's going to be negative 2. 4 plus 7. So it's going to be negative 2 to the power of 11. And I just leave it in form of a power. Here's the second law. If you have the same base and they're being divided, you can subtract the exponents. So that's the second law. So here, we're going to apply the same reasoning. I do have the same base, negative 9. Negative 9 is my base. So same base. I'm going to write my base again, negative 9. And I'm just going to subtract my exponents. So 10 minus 6. So my base remains the same, 4. So that's my answer. Negative 9 to the power of 4. And I leave my answer in form of a power. Unless it's if it says evaluate after, evaluate, then you would actually have to do negative 9 multiplied by negative 9 multiplied by negative 9 multiplied by negative 9. All right, finally here, I have 3 bases. So I'm going to have to go back to the first law. When I'm multiplying, I have to add my exponents. So I'm going to do that first. So it's going to be 3 to the power of 6. But then I have to subtract these two. So it's going to be 3 to the power of 6 minus 3. And my final answer will be 3 to the power of 3. I could evaluate that, but it doesn't ask me. It just says leave it in the form of a power. So 3 to the power of 3. And a final example. Here it says evaluate. So here I have to evaluate. So to evaluate, I'm going to use a couple of laws to make it simpler because that's why the laws exist. It's just to make my life easier. So 3 plus negative 2, I can just add my exponents here. So this is the same as plus negative 2, so 6 to the power of 1, plus, I have to do my exponent, this is 32, 36. So 36 plus 6 is 42. Again, I'm going to use my laws to simplify this because this looks pretty complicated. But look, I have the same base in the here inside the brackets, right there. So I have the same base. I can simplify this to negative 10, and my exponents would be 6 minus 4. So that would give me, that's inside these brackets. I still have minus 10 exponent 7, minus 10, oh, exponent 4. So this would be minus 10 squared. All right, so 10 is not a bad one to calculate because it's easy to evaluate. But here I can still simplify because these two here are multiplied together. See, when I have a bracket, oh, there's a bracket here. when I have the same base, negative 10, and they're multiplied together, I can add my exponent. So I have negative 10 here to the power of 6, because 4 plus 2 minus 10 to the power of 7. So here, 6 to the power of 10 is 10 times 10. So basically, it's going to be, I know it's going to be positive because I have a number, an even exponent. If I have an even exponent and a negative base, it's going to be positive. So I know my answer is going to be positive. And I just basically have 1 with 6 zeros. And I have to subtract 1 with 7 zeros. So what's the difference between these two? Well, it's negative 900. So it's 10 million minus 1 million minus 10 million is going to be minus 9 million. That's my answer. Here's your practice. Make sure you check your work behind the book.